today's tutorial, we will be looking at an Ethernet cable and work through the process of attaching a new connector to the cable. Ethernet cables are used to connect computers, servers, and other devices to a wired network. Familiarizing yourself with a network cable is a foundation that can be extremely helpful when troubleshooting network connectivity issues. So today we have a Cat5 cable that we'll be using for this example. Cat5 cables are a type of twisted pair which contain 4 pairs of twisted wires. We can tell our cable is a Cat5 cable by looking at the sheathing of the cable, that's this outer layer, where it is stamped with the Cat5 designation. There are other common forms of twisted pair Ethernet cables such as a Cat6 and a Cat6A. These cables still have 4 pairs of wires within them, but are more suitable for higher speed networking. All 3 types of network cables mentioned share common connectors for plugging in devices. This is an RJ45 connector, which has 8 contacts and is crimped onto the network cable, having one clip on one side that holds the network cable into a device. If we inspect the RJ45 connector that is on this cable, we see the colored wires inside of the cable. These wires are arranged into one of 2 standards. The following are EIA, TIA 568, and EIA, TIA 56B. I'm going to take a second and put these 2 color patterns up in an image on the screen. The color pattern for T568A is green, white, green, orange, white, blue, blue, white, orange, brown, white, brown. Now this cable is a T568B, and the color pattern again is orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. The more common of the 2 standards is the T568B standard. It is important that both ends of the network cable have the same standard applied to ensure proper communication between the network devices. Utilizing these standards for wiring patterns within a network helps simplify troubleshooting, as only 2 patterns will typically be used. As a side note, as long as both ends of the network cable share the same wiring pattern, the cable has a very good probability of functioning normally. Now, looking back at our network cable, let's discuss putting on a new RJ45 connector and verifying proper functionality once we've done that. To do this, we have our set of tools. We have the network cable that we'll be using today. We have our new RJ45 connects. We have a wire stripper designed specifically for network cables, and a crimping tool designed for RJ45 connectors, and a network cable tester, often referred to as a continuity tester. So for today's demonstration, because I already have connectors on the end, I'll begin by cutting off the current RJ45 connector from the cable. Now, if you have just a plain cable, you can go ahead and skip this step. Just note you'll have to attach connectors on both ends. Now that I've removed the RJ45 connector, I'll be using the wire stripper to score the sheathing of the Ethernet cable so that I can remove it. Removing more sheathing can make arranging the wires in a later step easier, but we don't want to remove too much because we may be shortening our cable too much or have too much excess wire. So we'll remove about 1 to 2 inches of the sheathing for our demo. Once you have the wire stripper on the cable, 1 full circle. We don't need to press hard, and we actually want to avoid pressing hard to avoid potentially damaging or cutting any of the wires inside. So once we've done 1 full circle, go ahead and bend and wiggle your wires free. Now, if your wires are bound really tightly inside, one of our pro tips is to take the sheathing around one of the wires, follow the twist, squeeze and pull. And you'll notice that it's separated, but this pulling practice also helps to straighten the wire. Once they're straight, we'll get them out of the way. Now these wires aren't too tightly bound, so this step is not as critical as if the wires were really tight or tightly bound together. And you'll see I'm able to just slowly unravel them and pull, have the same similar effect. So we'll get all of our wires kind of stretched out so we can start to put our pattern together. Want to make sure that we reach the bottom of the twisted pairs. Okay, so holding the cable in my non-dominant hand, I'm going to start pulling individual wires into place for that EIA TIA 568B standard we talked about. Double check that pattern here. Orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. Now, in order to get these wires into the jack, we're going to have to cut some of it off so that it sizes or fits more appropriately. Keeping all 8 wires pinched in between my fingers, I'm going to cut the wires so that they're shorter to only about 1/2 inch in length. And a good rule of thumb is to align the end of your fingernail bed, the top of the sheathing. Want to make sure that as we're checking, we don't disrupt our pattern. Get them nice and snug. And we'll cut. Cutting this will not only make the wire shorter, but it'll also even out the length to ensure a consistent connection for all 8 wires once we put it into the connector. So we'll pick up the RJ45 connector. There's a clip on it. We want that clip facing away from us so that the little grooves where each wire will go into is exposed. We'll be sliding 8 wires into the connector. Now this may take some time. You might not get it right on your first time. Just go ahead and try again. So ensure that each wire is in its own separate groove and that all the wires are lined up properly. Individual wires should push all the way to the top. Now that the connector is loosely applied, we need to go ahead and crimp the connector onto the network cable. So we'll be placing the RJ45 connector into the appropriate spot on our crimping tool in a direction away from us. I'm going to simultaneously apply pressure onto the network cable so I can ensure the individual wires remain in place, and I'll tightly squeeze the crimping tool to press the RJ45 connector onto the network cable. At this point, we've finished putting the new connector on, and we'll go ahead and validate that this network cable functions properly. So we'll need that continuity tester. And to utilize this, we have to plug both ends of our cables into the cable tester and cycle through all 8 wires. If it is properly wired, the light on the left-hand side will light up with the same number simultaneously on the right-hand side. This indicates that the cable should function properly. If the lights do not match between the 2 sides, we may have to cut off a connector and start over, or possibly replace the entire network cable. So remember, if you had just a plain Cat5 cable, you'll have to put on an RJ45 connector on both ends to validate or complete this testing portion. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. So both sides of the cable match. Now, if you are new to this process, this may take a couple of attempts to get right. Being familiar with this process and replacing connectors on these network cables can be useful because they're a very common source of network connection errors. The RJ45 connector may be damaged, the retaining clip may become loose or break off, or a portion of the network cable could be damaged from moving devices around. So if any portion of this clip is damaged or it can't be held properly into the device, we could have problems with connections. It's often easier to simply replace the RJ45 connector on a cable if the Ethernet cable is tucked away behind desks, tied up. So not always will we be able to see the entirety of the cable, especially if cables run over long distances. We can avoid the need to replace or rerun entire existing Ethernet cables by taking just a few moments to replace and test the connectors on the ends. I hope you found this tutorial helpful and consider replacing damaged ends of network cables instead of purchasing or buying entirely new network cables in the future. If you like this tutorial, follow and subscribe for more.